Hello dear students, welcome to the another session of the hydrocarbon chapter. In part 1 video, we already discussed about alkanes and alkenes, the complete name reactions and the important conversion questions and reactions and all. So here we are going to study the next topic, alkynes and benzene, aromatic compound, the most sure area, benzene compounds. Okay. First, let's discuss about alkyne. You may study in this area only two preparation of alkyne. One is from calcium carbide. That's the first question. Let me add. How will you prepare acetylene from calcium carbide? What is first of all acetylene? Acetylene is nothing but ethine. Okay, C2H2. Ethine is also called what? Acetylene. What is calcium carbide? CaC2. Okay, calcium carbide is CaC2. Simple reaction. Calcium carbide when hydrolyzed, you will get calcium hydroxide and acetylene. That means ethine. Keep in mind all of you, calcium carbide on hydrolysis, we will get calcium hydroxide and acetylene. That's it. So this is the way you can prepare ethine from calcium carbide. One of the simplest question. Next one. How will you prepare alkyne from vicinal dihalide? I told you there is only two methods for preparing alkyne. One is calcium carbide, from which you can prepare only which one? Ethine, acetylene. But vicinal dihalide, let me take one vicinal dihalide for example. CH2Cl, CH2Cl. Is it a vicinal dihalide? Yes, both of the halogens are on adjacent carbon. You may studied or we discussed in the first video about the beta elimination, right? What is the reagent we are using there? Alcoholic KOH. So take alcoholic KOH, let's do beta elimination. What is beta elimination? One of the halogen go from alpha, one hydrogen take from beta, make a double bond between alpha beta. You will get CH2 double bond CHCl. Correct? Okay. Now, we want alkyne, right? Now it's only alkene. Once again, we have to do beta elimination, but this time we are using NaNH2. This is called sodamide. Hope you remember soda lime. Okay, don't confuse. Soda lime is decarboxylation reaction, NaOH and CaO. This is sodamide. So if you want to convert a vicinal dihalide to an alkyne, two times we have to do a beta elimination almost. First we are doing with alcoholic KOH, second with the sodamide, NaNH2. Procedure same, halogen take from alpha, hydrogen take from beta, put one more bond. What it become? A triple bond. Yes, we are getting an alkyne. Clear all of you? This is the way you can prepare a alkyne from vicinal dihalide. So what are the two methods for preparing alkyne? One is from calcium carbide, one is from vicinal dihalide. Clear? Next one. There is a sure question you can expect from the area of alkyne, that is acidity. Very sure question from acidity. Let me tell you the theory first. Dear all, first point, the order of acidity. Order of acidity is alkynes are more acidic than alkenes. Then we have alkanes. This is the order of acidity. Alkyne. Generally, alkynes are more acidic than alkene, then alkane. Okay. So, ine, ane. This is the order of acidity. Reason is their S character. Alkynes are sp hybridized. Alkenes are sp2 hybridized. And alkanes are sp hybridized. Sorry, sp3 hybridized. Once again, alkynes are sp, alkene carbons are sp2, alkanes are sp3. Where you have more S character, you may study it. sp hybridization mean half percentage S character, half percentage P character, right? So here 50% S character. What character? S character. What about sp2? 33.3% S character. What about sp3? Only 25% S character. So can you say how S character related to acidity? As S character increases, acidity increases. I'm not going for detail. Actually, it is point is higher the S character, higher the electronegative, the carbon. So you can leave the hydrogen faster. It is more acidic. Generally, we can able to recover like this. Higher the S character, higher the acidity. Clear all? Okay. Higher the S character, higher the acidity. Okay. So generally alkynes most, then alkene, then alkane. Clear? Let's go for the question. Arrange the following in increasing order of acidity. First one, ethane. Let me mark it as this all set A, second compound B, third compound C. Okay, dear all. Tell me. You have ethane, ethene, ethyne. That already we said. You classify them as alkane, alkene, alkyne. Which is alkyne, ethyne. So C is most. Then alkene is B and alkane is A. Right? This is the order of first case. But second case, listen carefully. The second question, B question. What is ethine? CH triple bond CH. What is butadiene? Butadiene is CH3C triple bond CCH3. What is buta-1-ine? CH3 CH2 C triple bond CH. This is buta-1-ine. Arrange these in increasing order of acidity. Generally, we have an order alkyne, alkene, alkane, right? But here all are alkynes. So what to do? Check. Here, these triple bonded carbons are sp. Here, these are the triple bonded carbon sp. And these are the sp. Sp carbon if there, it doesn't more acidic. What is the need? The sp carbon, whether it contain hydrogen or not, you check. This sp carbon, yes, both of these two hydrogens are acidic. There are two hydrogen acidic. You can donate as H+. But in these two sp carbon, is there any hydrogen? No. So it is least acidic. What about these two? There is at least one hydrogen. So which is more acidic, dear all? A is more acidic. Then C, least B. So what is the thing? If all are alkyne, check on the triple bonded carbon whether there is a hydrogen or not. That hydrogens are acidic. It can donate two hydrogen, more acidic. It can donate only one H, therefore C, and B, no hydrogen. Can you say what about benzene, hexane, ethyne? This is easy. Benzene is an alkene, hexane is an alkane, ethyne is an alkyne. So which is more acidic? Ethyne is more acidic. I'm saying the third question, okay? Ethyne is more acidic than alkene, that is benzene, and least one hexane. Clear all of you? So conclusion, alkynes are more acidic than alkene because of S character. Higher the S character, higher the acidity. And if all are alkynes given, check on the triple bonded carbon whether there is a hydrogen or not. If there are more hydrogen, it will be more acidic. Clear all? Okay. Next question. What happens when ethyne and propyne? I'm asking as a two question, okay? Ethyne. What is ethyne? Carefully study this reaction all. This is ethyne and other one is propyne. Okay, this is ethyne and propyne. What happens when ethyne and propyne react with the water? H2O. It's actually warming, right? Heating. In presence of HgSO4, what is HgSO4? Mercuric sulfate and H2SO4. Heat is required there. HgSO4 and H2SO4. Okay. So study this reaction all, dear. Very important reaction. I think both of the reactants are alkynes, right? When alkynes react with the water in presence of mercuric sulfate and H2SO4, basically it follow addition reaction. H2O contain H plus and OH minus, right? H plus and OH minus. Okay, correct. Okay. Can you say this alkyne is symmetrical or unsymmetrical? I think this is symmetrical alkyne because both of the carbon carry one hydrogen. I think this is an unsymmetrical alkyne, right? Unsymmetrical alkynes and addendum contain positive, negative part mean we will follow Markovnikov rule. Can you apply Markovnikov rule here? Negative part goes to carbon with less hydrogen, positive part to more hydrogen. I think you will get CH3, COH, double bond CH2. Okay. Dear all, in the first case, this is a symmetrical alkyne. How you do the addition of water? In symmetrical alkyne, there is no carbon with less and more hydrogen, right? So as per your wish, H plus to one, OH to other. So let me add H plus to this one, OH to this one. So we will get CH, OH, double bond, CH2. Okay, dear all. So first case we didn't apply Markovnikov rule because it's a symmetrical alkyne, and this is unsymmetrical, we did Markovnikov. Clear all? Now, this compound we call it as enol because it contains ene and ol. Alkene and alcohol is there. Even this also contains ene and ol is called enol. Okay. It will undergo, if enol form, dear all, it won't stop there. It will undergo one isomerism. You may study that. It's called tautomerism. Here also undergo tautomerism. Please draw a double-headed arrow because it is reversible. How to do tautomerism? Very simple. Can you see the alcohol group OH? From which take the H and just transfer into this carbon. What we did, from the OH, take the hydrogen, it go to the other carbon. How to draw the same way here? This hydrogen go to this carbon. So can you say the final product, dear all? The final product will be what you have, this hydrogen overall reached here. So CH2 become CH3. This double bond becomes single bond, and this will be CH double bond O. What is CH3 CHO? Aldehyde. CH3 CHO, what we call ethanol. Same way, all of you pause the video, just do this one and tell me the product name. So this hydrogen reached here, so it will be CH3 C double bond O CH3. What it is called? Propan 2-on or acetone. You know, propan 2-on is also called what? Acetone. Okay, so generally to an alkyne, when you add water in presence of mercuric sulfate and H2SO4, it converted to what? This aldehyde or ketone from enol is called the tautomerism part. It's very important. It's only in which one? Alkyne. Okay, alkyne with the water, with the mercuric sulfate. Clear all? Practice again. Now, how will you convert ethyne to benzene? One of the most important reaction and simple procedure. Let me take ethyne, okay? 3 molecules of ethyne, let me take it. This is one ethyne. And what is other name of ethyne? Acetylene, don't forget. This is one ethyne, this is second ethyne, and this is third ethyne. 1, 2, 3, and passing through a red hot iron tube. Okay, at a very high temperature, 873 Kelvin. What we are doing here? 3 molecules of acetylene or ethyne passing through red hot iron tube at 873. What happened? It undergo cyclic polymerization. It undergo cyclic polymerization. What is cyclic polymerization? This double bond just shift like this. This double bond become the triple bond becomes double bond, and here it becomes single bond. So double, single, double, single, double, single. What is that? With the 6 carbon, we call it as benzene. So how will you convert ethyne to benzene? Through cyclic polymerization. Passing 3 molecules of ethyne through red hot iron tube, we will get benzene. Clear all of you? This is a very important reaction, and name notice that cyclic polymerization. Okay, study very well. Now the main part of the chapter we are beginning. The beginning part of the chapter okay. Now the main part of the topic we are begins here. The aromatic compounds. Aromatic compounds. Okay. You know, aromatic compounds are generally dealing with what? Benzene type of compounds. Correct? Okay. First question. Just question answer way you try this one. Okay, no need to take a detailed one. Explain Huckel's rule. Okay, Huckel's rule. You may study it. First one. There are Huckel's rule. First one. It is used to explain. It is used to explain whether the compound is aromatic or not. Okay. Whether this compound is aromatic or not, we can explain by the use of which one? Huckel's rule. Okay, Huckel's rule. So Huckel's rule is used to explain whether the compound is aromatic or not. And let's see what are the, okay, before going to the other question, let's see what are the rules or what are the criteria to make it a compound aromatic. One is the compound should be planar. How we can understand whether the compound is planar or not? The hybridization of each element, the carbon especially, it should be sp2. Okay, so the compound, first condition to occur or for Haeckel's rule is compound should be planar. Planar mean the carbon should be sp2 hybridized. The element should be sp2 hybridized. Okay, especially carbon. And how you can able to understand whether it is sp2 or not? Dear all, generally double bonded carbons are sp2. Double bonded carbons are sp2. Carbocation also sp2. Carbocation also sp2. Keep in mind. Second one, it should contain 4n plus 2 pi electrons. What? The compound should contain 4n plus 2 pi electron. What is n value? Here n value can be 0, 1, 2, 3, etc. If n value equal to 0, how many pi electron will be there? 2 pi electron. If n value equal to 1, 4 into 1 plus 2, 6 pi electron. If n value 2, 8 plus 2, 10 pi electron. If n value equal to 3, 12 plus 2, 14 pi electron. Basically ask this one. Okay, it continues. So generally 2 pi electron, 6 pi electron, 10 pi electron, 14 pi electron, they are belongs to what? Our 4n plus 2 pi electron system. And last rule is that the delocalization of pi electron, which means resonance should happen. The compound should undergo resonance. These are the three things, or these are the three rules belongs to Haeckel's rule. So dear all, finally, Haeckel's rule is used to explain whether the compound is aromatic or not, and these are the three rules. What are they? Compound should be planar, compound should contain 4n plus 2 pi electron, and delocalization of pi electron. Keep in mind all of you, that's 2, 6, 10, 14 pi electrons are there. Let me give you a lot of example. Let's study. First one, benzene. Whether benzene is aromatic or not. We are studying yes, right. Why it is? Because it obeys Haeckel's rule. Let's show. First case, what is the hybridization of this each carbon? Each carbon is double bond connected carbon. They are sp2. So first condition, right. Now, how many total pi bonds are there? 1, 2, 3. 1 pi bond contain 2 electrons. So 3 pi bond contain 6 pi electron. Is it there in our system? Yes. Correct. Third one, the resonance is possible or not? Of course, alternate double and single bond if it come, of course what? Resonance is possible. Yes, resonance, delocalization of pi electron possible. So all three rules are satisfying, it's aromatic. Any rule one violating means it's not aromatic. Okay, so benzene is aromatic. Hope you clear this case, dear all. Now, second one, let me give you another example. Cyclobutadiene. Dear all, what about the hybridization of each carbon? All carbon having one double bond connection. Yes, sp2. How many pi bonds are there? 1, 2, 2 pi bond. 2 pi bond means 4 pi electron system. Is it there? 4 pi is not in our system, so it is not aromatic. Okay, no need to go for resonance. If any rule one violated means no need to go check the other one. Okay, so this is not aromatic. Next, third one, cyclooctatetraene. Octa, 8 carbon. Okay, 8 carbon with 4 double bond. Is it aromatic or not? Check it all. All carbons having sp2. Yes, all having one double bond connection. And it contains 4 pi electron. 4 pi bonds. 4 pi bond mean 8 pi electron. 8 pi electron is not in our system, so not aromatic. Next one. Consider about this case. It's a cyclopentane with a 2 double bond. It's with an anion. It's called a cyclopentadienyl anion. Whether it is aromatic or not. Dear all, this is sp2, 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 sp2. Actually, carb anions. I told you carbocations are sp2, but carb anions are sp3. But dear all, this lone pair also involved in resonance. This lone pair also involved in resonance. So it become a double bond. So this carbon become double bond connected carbon. So it become sp2. So all carbons are sp2. How many pi electrons are there? See dear all, 2, 4 means total 2 pi bond, right? 1, 2. 2 pi bond mean 4 pi electron. Even this lone pair also involved in resonance. So 2 more. So 6 pi electron. 6 pi electron. Yes, it is there in our system. And resonance possible or not? Yes, if it changed here, what happened? Resonance. Yes, all double bonds are in delocalization. Resonance is possible. So all cases are satisfying. So this compound is what? Aromatic. Let me give you one last example. Can you say this compound is aromatic or not? This compound is aromatic or not? If you check the hybridization, yes, all carbons are sp2, 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 even carbocation also sp2. First condition set. How many pi bonds are there? Only 2 pi bond. You know, 2 pi bond mean 4 pi electron. 4 pi electron, is it there in the system? No. So this is not aromatic. So this way you can analyze different kind of compound. Let me give you one last example. Naphthalene. You know, naphthalene, it's a combination of what? It's a fused one, 2 benzene ring. Naphthalene is aromatic or not? Check. See, all carbons having one double bond connection. sp2 is there, correct. An alternate double and single bond mean nothing to worry, a resonance should be possible. And how many pi electron? See, how many pi bond? 1, 2, 3, 4, 5. 5 pi bond mean 10 pi electron. Is it there? Yes, 10 is there. Yes, it is aromatic. Clear? So study what is Huckel's rule, the condition, and how can we explain whether it is aromatic or not. Clear all of you? Next one. Let's some reaction. Let's study. Complete the reaction. See, open the textbook, you can able to see all the reaction. First one. Sodium salt of benzoic acid react with soda lime. What happened? Sodium salt of benzoic. What is benzoic acid? Benzene with the COOH. If it is Na, it's called sodium salt of benzoic acid or sodium benzoate. It's treated with a soda lime. What is soda lime? NaOH and CaO. You know, soda lime reaction is called what? Decarboxylation. Correct. So dear all, in decarboxylation reaction, you know that one carbon less product you will get it. What do you mean by decarboxylation? Removal of carbon dioxide. See, this part you cut and remove. What is left? Benzene. You know the byproducts in decarboxylation what? Na2CO3. So dear all, it's a direct question for your exam. Sodium salt of benzoic acid when react with the soda lime, what we get? Benzene through decarboxylation. Second one, very important and easy reaction. What is phenol benzene with OH? What happened? Phenol heated with a zinc dust. Dear all, phenol when heated with a zinc dust, Zn, reducing agent, Zn will take this oxygen and go as ZnO. What is left in this one? That is benzene. So this is actually both of these are preparation of benzene, dear all. Sodium salt of benzoic acid when undergo decarboxylation, we get benzene. Phenol on reduction with zinc, also you will get benzene. Okay, next one. What happens when benzene react with? It's a direct question for your exam. They will ask you, mostly they will ask you with equation. What happen benzene react with hydrogen? In a textbook they given 3 hydrogen with what? Nickel and heat. What happened benzene react with hydrogen? You know, benzene is an unsaturated compound. Unsaturated compound when react with hydrogen, it becomes saturated. Why we are using 3 hydrogen there? If one H2, if you add, one double bond goes. So 3, or if you add 3 H2, all the double bond goes. What you will get, dear all? Cyclohexane. So benzene, when it undergo addition with the hydrogen, it becomes cyclohexane. All double bond get vanish. One more is there. What happened benzene when react with the chlorine in presence of UV light at 500 Kelvin. Keep in mind all of you, when benzene treated with the chlorine, actually we will add around 3 Cl2 there. All the chlorine get added on benzene ring. All the chlorine get added on benzene ring and double bond goes. You will get chlorine, 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 and this compound we call it as BHC, is known as benzene hexachloride. Benzene hexachloride. It's also called gamaxane. Also called gamaxane. Okay, so study all of you. Benzene when reacts with the hydrogen, it becomes what? Cyclohexane. Benzene react with the chlorine in light, you will get BHC, benzene hexachloride, also called gamaxine. Very important, okay? Basically, they ask you question. They will give you the reactant and reagent, write the product. That type. Now, write all electrophilic substitution reactions on benzene. Almost you are at the final stage of the chapter. Very important area. Carefully listen on. You may study all electrophilic substitution on benzene ring. What is mean by electrophilic substitution? On benzene, we want to add one electrophile. Electrophile mean a positively, basically a positively charged species or electron deficient species. Okay. You may study 5 electrophilic substitution on benzene, right? What are they? Benzene, you may study basically chlorination, right? 5 reaction you may study. Chlorination, second nitration, third sulfonation, fifth Friedel-Crafts. Yes or no? Friedel-Crafts, which one? Alkylation. What is the last one? Friedel-Crafts acylation. Right? These are the 5 reactions you may study under electrophilic substitution. What is chlorination? How you can add one chlorine on benzene ring? Add Cl2 with the catalyst anhydrous AlCl3, aluminum chloride. You will get chlorobenzene. What is this compound is called? Chlorobenzene. So study like this, dear, don't by heart. If I want to get a chlorine on benzene ring, what's the reagent I want to choose? Chlorine with anhydrous AlCl3. Nitration, so chlorination. Nitration mean addition of nitro group. What we are using? Concentrated HNO3 and concentrated H2SO4. These are the 2 reagents we are adding to get nitro group. So what is the compound we are going to get? Nitrobenzene. We get nitrobenzene. You will write and practice the reaction, important. What do you mean by sulfonation? We are adding fuming H2SO4, fuming sulfuric acid. Which group is coming to benzene ring? SO3H. Benzene with SO3H is called benzene sulfonic acid. What is Friedel-Crafts alkylation? Bringing alkyl group. For example, if you want methyl group, add methyl chloride with anhydrous AlCl3 catalyst. So the CH3 will come to benzene ring. Benzene with the CH3, what we call toluene. Last one, Friedel-Crafts acylation, adding acyl group. What is acyl? CH3 CO group with Cl and anhydrous AlCl3. So which group is coming? CH3CO come to benzene ring. So benzene with COCH3. Benzene with the COCH3 is called acetophenone. It's a ketone. These are the basic 5 reactions we are using in this as electrophilic substitution. What do you mean by electrophilic substitution, dear all? We are bringing some electrophile to benzene ring. During chlorination, which is the upcoming group, Cl as plus. As I told you, electrophiles are positively charged. During nitration, the upcoming group is NO2 plus. Sulfonation, that group is SO3H plus. Alkylation, any alkyl group. If we used methyl here, so which group is coming to this one? Methyl plus. During acylation, which group comes? CH3CO plus. CH3CO plus. These are the upcoming group to benzene ring. So this is the reactions we have to study in detail. Chlorination. So study here like this. If I want to bring a chlorine on benzene, what I want to choose? If I want to bring nitro, what is the reagent? If you want to bring in sulfonic acid, what's the reagent? If I want to make it toluene, what's the reagent? So dear all, just pause the video, study the reagents and the product. Okay. Now continue the next question. Explain the mechanism for electrophilic substitution, especially chlorination and nitration. They are basically preferred for your examination. Okay, very important. We just said now if you add this reagent, it will go to benzene like that. How it is happening really. So study the mechanism at least 2-3 times, write and practice all. Total there are 3 steps for the electrophilic substitution. First step is formation. First step is formation of electrophile. First step is the formation of electrophile. First electrophile should generate, then only we can add on benzene ring, right? So electrophile, let us generate. How they generate electrophile? Let's see. If it is chlorination, what is the reagent we are adding? Cl2, right? Let me write Cl2 like this one with what? Anhydrous AlCl3. Keep in mind all of you, AlCl3 is a electron deficient compound, okay? So one of the chlorine goes to AlCl3. AlCl3 is an electron deficient compound, it's a Lewis acid. One of the chlorine go to AlCl3 as Cl minus. So Cl minus, this Cl go as Cl minus, go to this AlCl3 become AlCl4 minus. What is the other Cl? It exists as plus. That is the electrophile. So this is the way chlorine plus electrophiles is generating. Let's see what about nitration. What about nitration? Nitration means what are the agents we are adding? Concentrated HNO3 and concentrated H2SO4, right? Listen all. First H2SO4, it breaks, it will give you H plus and HSO4 minus. What? First H2SO4 breaks to give H plus and HSO4 minus. This H plus taken by HNO3. HNO3, take this H plus, it becomes H2NO3 plus. First what they did? H2SO4 lose H plus and that H plus taken by HNO3. HNO3 become H2NO3 plus. Later this H2NO3 plus breaks give you which one? Our electrophile NO2 plus. What is left? Did all H2NO3 plus breaks, you are getting NO2 plus and what is left? H2O. This is the way NO2 plus is forming. Okay, this is the way chlorination Cl plus, nitration NO2 plus is forming. And Friedel-Crafts alkylation, acylation mean same thing. What happened? CH3Cl when you add, I told you AlCl3 is electron deficient. So this Cl go to AlCl3 as Cl minus. So this exists as what? CH3 plus. If this is the one, Cl go to AlCl3, this exists as what? CH3CO plus. These are the way the electrophiles are forming. So first step in electrophilic substitution is what? Formation of electrophile. Clear all? Good. Good. Second question. Now benzene ring. Let us invite our benzene ring to which what we are adding? Electrophile, right? Electrophile. If it is chlorine means Cl plus, nitro mean NO2 plus, like that. What is the step? Dear all, let me give a shortcut method. Textbook they given us like this. You may not understand what it is mean. Generally, when an electrophile come to benzene ring, the double bond shifted to one of the carbon. When an electrophile come to benzene ring, double bond shifted to one of the carbon. See, to this carbon, this electron shifted to this carbon. So mean this carbon losing and this carbon, all of you, this carbon losing and this carbon gaining. Correct or not? So if it is losing, it will get positive charge. If it is gaining, it will get negative charge. Am I right? So let me write these two double bond, nothing happen. Can you say where this electrophile get added? This carbon getting positive charge, this carbon getting negative charge. So where electrophile get added? On the negative carbon, right? So electrophile will be there. Already one hydrogen is there. Already one hydrogen is there, right? Yes. And this carbon, sorry. Really it's a mistake dear all. Sorry for that. It's not correct. Because this carbon losing, this carbon gaining, right? So it will get negative charge, it will get what? Positive charge. Hope you may notice that. Good. So where electrophile goes to the negative carbon. So we will get the benzene. There's nothing happen, this double bond. And this electrophile go to this carbon. Already one hydrogen is there. and this carbon exists as a carbocation, right? Carbocation. Even there is also one hydrogen, right? Here also we have one hydrogen. That's only the benzene contain hydrogen. Okay. So what happened in the so I told you in textbook how they mention it is they given just like this taking the E plus. This is the way they're taking E plus. So what is happening in second step? When an electrophile come to benzene, one of the double bond shifted to one carbon, the carbon get negative and positive. To the negative carbon, electrophile get attacked. Okay, this is the way. What is the name of the second step? We can able to say formation of carbocation. Attack of electrophile and formation of carbocation. Are you getting a carbocation here? Yes. Okay. Now what is left here all? We need to get the electrophile on benzene. Already electrophile come to benzene, but it's not benzene now, right? How they back to benzene? That's the third step. Let me write this compound once again. Okay, this is the one we have. There is an electrophile and there is a H and there is also one H and plus charge. Dear all, carefully listen. You may notice in first step there is something formed AlCl4 minus, right? This AlCl4 minus, what to do that? Dear all, this AlCl4 minus to this H plus goes. This H from this electrophile connected carbon, this H go to AlCl4 minus. Let me tell you, this H is going as H plus, okay. So this bond shifted here, you will get the benzene back. You will get the benzene back. This carbon getting electrons, so positive charge vanish, you will get the electrophile. What is the byproduct? Means the benzene ring formed back. This H is taken by AlCl3, AlCl4 minus. You will get one H, one of the Cl. It taken as HCl and remaining is what? AlCl3 getting back. This is the way electrophiles are generating. Once again, let me explain all of you. There are total 3 steps in electrophilic substitution. First is formation of electrophile, generation of electrophile. First case what to do means, it is chlorination this way. Keep in mind AlCl3 is an electron deficient compound, so it will take the chlorine. Okay, so one Cl plus, other Cl AlCl4 minus. Nitration means this way NO2 plus forming. After generating electrophile, in second step to the benzene we will add the electrophile like this. After that, the proton, the H plus, what do you call H plus? H plus is called the proton, right? This proton is taken by AlCl4 minus. This process we call it as deprotonation. Removal of proton we call deprotonation. What is proton? H plus. By the way, we are getting electrophilic substitution. Clear all of you? This is the way to study the electrophilic substitution. What are the electrophilic substitutions studied? Chlorination, nitration, sulfonation, Friedel-Crafts alkylation and acylation. Now there is 100% sure question for your exam in this part, this conversion. Any two conversion of this. Carefully listen on. How will you convert benzene to? I'm not making a complicated and detailed explanation here. Let me make the concept simple how to answer this question. Dear all, there are 2 type of groups. Ortho-para directing groups and meta-directing groups. Okay, please note the list. Ortho-para directing group and meta-directing groups. Which all are ortho-para directing group? Note it, ortho-para directing groups are electron donating groups. Meta-directing groups are electron withdrawing groups. What? Ortho-para directing groups are electron donating group or meta-directing groups are electron donating group. Please note the list. Which all are ortho, para and meta? Alcohol, amines, any alkyl group, any alkoxy group, etc. These all are electron donating group and ortho, para directing group. Means, if any of this group present on benzene ring, for example, I have a benzene with OH. You know, benzene with OH is, see, OH is a donating group. It's an ortho-para, which means this is phenol, to which if you add an electrophile, it can go to its ortho and para position only. It won't go to meta. This is called ortho-para. They will direct the next electrophile to their ortho and para. So what do you mean by meta-directing group? They will direct the electrophile to their meta position only. Which all are withdrawing group? Not at all. Nitro group is a very withdrawing group. Acid is withdrawing group. Aldehyde is withdrawing group. Ketone is withdrawing group. Cyanide is withdrawing group. These all are what? Withdrawing groups. If any of this group present on benzene ring, for example, nitrobenzene. First you consider nitro is what kind of group? Nitro is a withdrawing group. Withdrawing group, which one? Meta-directing. So it is compulsory to know which all are ortho-para-directing groups and meta-directing groups. If nitro group comes, the electrophile can go to only meta position. Okay, so study which all are, pause the video and study which all are ortho-para-directing groups and all. Now let me perform how to do this reaction. Question, how will you convert benzene to, all of you very carefully, is a symbol. How will you convert benzene to para-nitrochlorobenzene? Okay, para-nitrochlorobenzene. How to get nitro group? Nitration. We will add concentrated HNO3 and concentrated H2SO4. How to get chlorine on benzene? Add Cl2 with anhydrous AlCl. That you studied, right? Perfect. Now, how to analyze? Dear all, see the first question. How will you convert benzene to para-nitro? Para. You want the product in para. But in second question, you need in meta. Third question, again para, like that. So, see the product which you want. You want para. If you want para, the ortho-para directing group, add first. Finally, once again, your product is para. If you want para product, the ortho-para directing group, add first. Nitro, chloro. As I told you, nitro is which one? Meta-directing. Chlorine is a halogen, right? They're all halogens. Please add it. It belongs to ortho-para directing group. Let me add halogen also here. So nitro is a meta-directing group. Chlorine is a ortho-para. So among that, which is the ortho-para one, add first. Then only you will get para product. So let me add chlorine first. How to add chlorine? Cl2 with anhydrous AlCl3. You will get chlorobenzene. Now dear all, chlorine will decide where the next group to go. Chlorine is a halogen. I told you halogens are ortho-para directing group. Next group can go to para. That's what we need. So do nitration next. Concentrated HNO3, concentrated H2SO4. We get chlorobenzene with one nitro group on para. Why we are not doing nitration first? If you add to benzene nitration, nitrobenzene, you will get it. Nitro is a meta-directing group. So next group can go to meta. We want in para. Let me do one more question. B. How will you convert benzene to meta-nitrobromobenzene? We didn't study right how to get bromine, right? Don't worry. How to get chlorine? Cl2 with anhydrous AlCl3 catalyst. If you want bromine, add Br2 with the FeBr3 catalyst. Okay, FeBr3. For chlorine, AlCl3, bromine, FeBr3. Even AlCl3 fine. Which will do first? That's a question. You want the product. See the product, all of you. You want the product in meta, right? So the meta directing group, add first. Which is meta-directing group? Nitro. So do nitration first. So add concentrated HNO3 and concentrated H2SO4. We get nitrobenzene. Now nitro group is a meta-directing group, right? He will direct the next group to meta. Yes, that's what we need. So do bromination. Add Br2 with the catalyst FeBr3. So we will get nitro and bromine. See, meta-bromo or meta-nitro-bromobenzene. Clear all? Next one. Can you pause the video and try the C? Then you later watch it. Para-nitrotoluene. Nitro means, nitro means meta-directing group. What is toluene mean? CH3 we need to bring. That is Friedel-Crafts alkylation. Correct. You know, nitro is a meta-directing. Alkyl groups are ortho-para-directing. See your product, you want para. If you want para, the ortho-para-directing group add first. So let me do Friedel-Crafts alkylation first. CH3Cl with N-hydrous AlCl3, we get toluene. This toluene on which do nitration, that is concentrated HNO3 and concentrated H2SO4, we get toluene with the CH3 nitro group on which position? Para position. And the D question is a direct one. What is acetophenone? That you do Friedel-Crafts acylation. What is Friedel-Crafts acylation? Treat with CH3COCl. What is this called? Acetyl ethanoyl chloride or acetyl chloride. It's ethanoyl chloride when treated with N-hydrous AlCl3. What happened? The COCH3 come to benzene ring. You will get benzene with COCH3 called acetophenone. This is direct. Benzene on Friedel-Crafts acylation, we get acetophenone. Clear all of you? Sure question. So here you study which all are ortho-para directing group and meta-directing group. Okay, clear? Ortho-para directing group, study the list. Meta-directing group, study the list. See the product you want. If you want a para product, the ortho-para directing group add first. If you want a meta, add meta-directing group first. Clear? Okay. Now, arrange the following compound in order of their decreasing relative reactivity with electrophile. What is that compound given? Toluene, right? Toluene. Benzene with CH3. Next, benzene. The other one, nitrobenzene. Question, which will undergo electrophilic substitution faster? Suppose you have an electrophile, whether chlorine, nitro, whatever. Where it go faster? Simple idea. Listen all of you carefully. What kind of group is alkyl group? I told you all alkyl groups are electron donating group. Correct. What is nitro group? Nitro is an electron withdrawing group, a meta-directing group. What is done by an electron donating group on benzene? They will donate electrons to benzene ring, right? They will donate, they will give electrons to benzene ring. So benzene become electron rich. Benzene become electron rich. Correct? Good. In benzene, no special groups, okay? What happened to electron withdrawing group? Electron withdrawing group means they will withdraw, they will take electron from benzene ring. So benzene become electron deficient. This is correct for any donating and withdrawing cases, right? Any donating group present, benzene will be electron rich. Withdrawing group in present mean benzene will be electron deficient. What is electrophile? Electrophile is already electron deficient. Therefore, it's positive charge. So, where it prefer to attack? Electron rich. So, it will go to this side. That's it. So, which will undergo reaction faster, dear all? Toluene undergo reaction faster. They said they arrange the decreasing order of reactivity. So, toluene, let me, okay. Toluene is the most reactive. After that, which one? Benzene. Okay, after that benzene and then nitrobenzene. So what is the conclusion, all of you? Electrophilic substitution can happen more if there is a electron donating group. Because electron donating group, it's compulsory to know the list of electron donating group, okay? If there is a electron donating group, the benzene ring will be what? Electron rich. Electrophile can easily attack. Clear? Okay. Why benzene come in the middle? Because this is the least one, because there is an electron withdrawing group. So basically electron donating group or activating group for electrophilic substitution. One more question let me give you. Chlorobenzene, same question. One is chlorobenzene. One is para-nitrochlorobenzene. Para-nitrochlorobenzene. The other one is 2,4-dinitrochlorobenzene. 2,4-dinitrochlorobenzene. Can you say fast, dear all? Can you say fast, dear all? All compound chlorobenzene is common. What is different? Nitro group is there. You know that nitro group is a withdrawing group, withdrawing group, withdrawing group. Just we said now, only electron donating group will activate the ring for electrophile attack. Here electron withdrawing group, if it present more, its reactivity decreases. So which is most reactive? This. Least reactive? This. Correct? Because it having more electron withdrawing group. Clear all of you? Perfect, right? Good. Keep going. Now let me show you some of the reaction what they can ask directly from the NCERT textbook. Complete the reaction. Last is said, now you studied, watch the part 1, part 2 video for hydrocarbon and you are mostly familiar with all of the reaction. Try to recollect and complete the reaction. Dear all, what is first reaction? A alkane react with a chlorine in presence of HNu. HNu means light. What is this reaction? Substitution. What do you have to do in substitution? Remove one H, remove one Cl, HCl, take it out. What is left? CH3, CH2, Cl. You will get haloalkane. Right? Alkane on halogenation you will get, or substitution you will get haloalkane. This reaction you may remember, this is hexane. Hexane, when it undergo, what is this reaction called? Aromatization, right? Hexane on aromatization. What is the product here all? We will get benzene. Correct? Last one. Next one. This is a propine. Propine is an alkyne. Alkyne to which normally if you add hydrogen with a normal catalyst, what we get? Alkene. Propine becomes propene. But 2 times they are adding hydrogen, so it become what? Directly go to what? Propane. We can directly write propane. Okay. So alkyne on hydrogenation, first it become alkene, then again hydrogenation you will get alkane. They already mentioned 2 hydrogen, so it end with alkene. Now, what happened in this reaction? Chloromethane is given. It's a haloalkane with H, hydrogen. We know haloalkane react with the hydrogen with the zinc and acid. 1 HCl cut. What you will get? What you will get? You will get CH4, methane. Correct? What is sodium and dry ether mean, dear all? Woods reaction, right? This is our Woods reaction. This is the Woods reaction. What is Woods reaction? When 2 same haloalkane react with the sodium and dry ether, the alkyl group get joined. You will get C2H5, C2H5, that is butane with the what? 2NABR, right? You'll get butane. What is this? Sodium salt of ethanoic acid. Sodium ethanoate reacting with the soda lime. That is decarboxylation. You know, in decarboxylation, 1 carbon less alkane get it. It's ether, so your product is methane. You know the byproduct in decarboxylation? Na2CO3. Correct, dear all? Can you follow it? Next. What happens? Sodium salt of ethanoic acid or sodium acetate with the water and passing electricity. What is this reaction? Kolb's electrolysis. Kolb's electrolysis byproduct, hope you remember, they are NaOH, carbon dioxide and hydrogen gas. What is the product? How to write the product in Kolb's? Double the alkyl group. The alkyl group double. CH3 becomes CH3, CH3. You will get ethane. Clear all? Next one. What happened? What is this compound? CH2Br, CH2Br. It's a vicinal dihalide treated with a zinc. Zinc that will take both of the bromine. You will get ZnBr2 out. What is the product? CH2 double bond CH2. It's a preparation of alkene from vicinal dihalide. What is concentrated H2SO4 function? Concentrated H2SO4 mean dehydration. See all of you, this is an alcohol. CH3, CH2, OH. It's ethanol. So how you remove water from this one? Alcohol remove from alpha. Take one of the hydrogen from beta. Make a double bond between alpha beta. What is left? CH2 double bond CH2. Ethene will form. Yes or no? Alcohol on dehydration with H2SO4 we get alkene. What is this? To an alkene, when you add bromine with a CCl4 or bromine water, right? See dear all, 1 bromine go to this carbon, 1 bromine go to this carbon, we'll get CH2Br, CH2Br. You will get vicinal dihalide, and this test to be studied as a distinguishing test for unsaturated compound, right? Unsaturated compound can react with the bromine water, reddish brown color, it become colorless, right? What is this? It is a unsymmetrical alkene to which HBr added an addendum. It is in the absence of peroxide. Follow Marconico's rule. Negative part goes to carbon with less hydrogen. Positive part goes to more hydrogen, you will get Br on this carbon, right? You are following which one? Markovnikov's rule, you may get it. And what about this one? This is an alkene, a unsymmetrical alkene adding water. Water contain H plus and OH minus. Yes, we can follow Markovnikov rule. Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. We will get CH3, C, CH3, OH and then CH3, right? Here also we are following what? Markovnikov's rule. What is this reagent, dear all? Do you remember? H2O, O dilute KMnO4. That is our Bayer's reagent. As I told you, Bayer's reagent means take two OH group, put it on the double bonded carbon symbol. You will get CH2OH, single bond CH2OH. And I told you, if two OH group on carbon coming on the same carbon, sorry, adjacent carbon, what we call glycol. Right? What about this one? An alkene treated with ozone, ozonolysis. What is the first step in ozonolysis? Cut the double bond, cut the double bond and cut the double bond, place the oxygen, one up, two oxygen down. We will get the ring structure called what? Ozonide. After that, zinc and water is given, break it left and right. What is the product left side here all? CH3, CO, CH3. You will get CH3, CO, CH3 plus what is the product right side? CH2O. What is CH2O? We write it as HCHO. You will get propan 2-on and methanol. Correct? Then, what is this reaction? Say fast, dear all. These three molecules of ethane, when passing through red hot iron tube at 873, cyclic polymerization happen. You will get benzene, the aromatic compound. What is the reaction called? Cyclic polymerization. What is this? Sodium salt of benzoic acid. When undergo decarboxylation, what we get? Benzene. These all are preparation of benzene. Phenol when treated with zinc. Zn take this oxygen. ZnO go out. And what we get? Benzene. This is also preparation of benzene from phenol. Phenol on reduction with the zinc, we get benzene. So dear all, one more cases. Benzene react with the concentrated HNO3 and concentrated H2SO4. What we get? Nitrobenzene. This is nitration. Correct or not? Benzene treated with the chloromethane with anhydrous AlCl3. It will go to benzene ring. It's called Friedel-Crafts what? Friedel-Crafts alkylation. Correct or not? What is this? Benzene with acetyl chloride or ethanoyl chloride. Friedel-Crafts acylation. COCH3 come to benzene ring. Benzene with COCH3. What we call it as acetophenone. What we call it as acetophenone. Right, dear all? These are all NCERT questions which is given. They will give you directly and complete the reaction. Such type of questions are most sure. So thank you everyone and watching this video. So hydrocarbons, the complete alkane. In between some reactions actually we missed that, like isomerism, like some reactions, right? Some oxidation. But I'm saying, I told you, basically for your examination, school examination, they will ask, especially the isomerism, ethene to polythene, like that. Some reactions we missed in between. I know that. But these are the basic master equations, majority equation they are going to ask for your upcoming school examination. Sure, watch this video once again and please write and practice the reaction. Try to memorize sometime naming reaction like what is happening in Wood's reaction. Don't by heart entire reactions like that. What is happening? I told you, Wood's reaction means these are the type of question. Ozonolysis means these are the type of question. So study each and every reactions thoroughly once again. Okay, so for the upcoming video, we will come with other chapters also, like thermodynamics, all most important reactions and all we discuss in detail. Most expected question we can discuss for your upcoming school examination. Let us make it maximum easier. Okay, so wish you all the very best and here all practice the maximum and repeatedly do the questions again. Thank you all. Wish you all the best. Very well. Thank you.